you can really tell the difference when someone is producing AI slop basically because they just said, Claude, go do something, versus when you tell the AI agent to execute after a few hours or however long it took to land on that really like sharp problem you're trying to solve. It's like sometimes, you end up with a PR that's like, oh, this is 15,000 line change. You definitely didn't look at this. I don't think anyone has seen this, and I don't think this should go to prod, but like that's generally not happening.
This podcast is hosted by Cortex.io. We help organizations continuously improve their operational maturity and reduce developer friction so that the whole organization operates as one. Check out the link in the description to see how we've helped our customers cut their MTTR in half, double their deploy frequency, and save thousands of engineering hours with golden paths and the right guardrails. Thanks for listening to Brain Trust, a podcast for engineering leaders by engineering leaders. Hey, Adam, thanks for joining me on the podcast. This is the Brain Trust by Cortex podcast, and I am Ganesh, co-founder and CTO at Cortex. Very excited to have you on today, obviously as a member of the Brain Trust community, and we've had a lot of very interesting conversations, especially around AI and security, so excited to chat more about that today with you. Thanks for joining me.
Yeah, thanks for inviting me. My name is Adam Berman. I'm excited to be on the podcast here. My background, I, until recently, was the VP of Engineering at Semgrep. And in February, stepped back into an IC role. So we can talk about that a little bit. Semgrep is a static analysis company focused on application security. So we spend a lot of our time thinking about how can we like quickly and in a developer-friendly way prevent and detect vulnerabilities. And we've talked a lot about AI and security, and AI is really changing things there. So we're doing a lot of really fun exploration, which is one of the reasons I got back into being an IC.
Excited to have you on. Well, I have a lot of questions about security and AI, but before we dive into that, I would love to hear a little bit more about that transition that you just mentioned from engineering leadership into being an IC. I have been seeing that a lot more. Actually, I just recorded an episode with another guest that went through a similar journey, and I think everyone is realizing it's a very unique time to be a software engineer and just be in this industry. And I think a lot of folks like yourself are deciding to maybe get their hands dirty for a little while before they figure out what's next. But yeah, I would love to hear about that decision. Like, what drew you back into being an IC? I mean, obviously, you had a very successful career as an engineering leader. Running engineering at Semgrep. What prompted this decision? Like, what led to this?
Yeah, I think I'd always been attracted. I mean, I came up through product engineering. I love building products. Like, the thing that gets me really excited is working like directly with customers, taking an idea, like building basically like hand in hand with our customers, that really quick feedback loop. And I got to do that really early on at Semgrep and previous roles, and helped to build our product portfolio. And I think like many people who end up as engineering leaders at startups, like I went through the calculation that the highest impact I could have to help Semgrep grow and succeed was to step into an engineering leadership role. I had done engineering leadership at previous companies, and to help like take the product engineering mindset that I had and help the rest of the company like think about product problems the same way. And I'm really proud of what we got to do over 2 years leading engineering there. And we got to scale the company and grow the product portfolio. But there came this time where I just felt like this itch. I just needed to get back into building. And that itch was really amplified, seeing builders around me getting to move so much faster with the AI tools that are now available, where like in the past, it really took a team of 3, 5, a 2-pizza team to build any product. And I think to build any product for real, you still need a 2-pizza team, but that exploration can really be compressed, especially in greenfield work. And I felt this like urge to, okay, I want to get my hands dirty again. I got to play with the tools a little bit and realize that like I kind of like looked at my calendar and was like, what can I take off of my plate to do more experimenting? And at some point I realized like, okay, I think I need to swap my order of priorities.
Yeah. Were you getting your hands dirty like outside? I mean, obviously it's very hard to find time when you're running into your organization to be building, but obviously it's a very drastic shift to kind of go back full time to being an IC. Did you get your hands dirty first and you're like, oh, this is awesome, I need to be doing more of this? Was it more like, I'm not getting enough time, and so therefore I must make a drastic decision? Like, what was the kind of calculus that went into that?
I think there were a couple things. One is just like the personal like itch, which like I was trying to satisfy. I play Ultimate Frisbee competitively, and I was like building an app for my team. I was like, how can we manage finances? How can we do our strategy better with an app? I was like, okay, like this is not enough. I need to dig into something a little meatier. And then I think the other part was thinking about like, what are the like risks and like areas like for opportunities for Semgrep as a whole. And I felt like, okay, I feel like what my job is taking me in the direction is making sure that like other people are managing that risk appropriately. Other people are exploring that appropriately. But it feels like the make or break here is not whether or not we ship everything on time. The make or break here is, do we have like as many of our best people as possible on some of these open-ended problems that don't have obvious solutions? And then I felt like, okay, I think that my best contribution to Semgrep will be going back in and seeing like, can I take one of those open-ended problems that could make or break, or that could make the company, like if it turns out that it like pans out, and like go drive that forward. And I think what I really love doing is like failing fast on many of those and having the skill set to fail fast on many of those, and then until you find the one that really will take off, and then shepherding that forward. And I feel like that became the calculus. It's like, okay, I think someone else could actually do this VPE job better than I could. And like, maybe I can go do the product engineering side in a way that like other people maybe at Semgrep like couldn't, or maybe that other people like, how can I like go help the product engineering side do it better?
Do you feel like that was primarily because of AI that this shift happened for you? Like, I think for me personally, I'm writing a lot more code than I ever have. I think it's easier to do greenfield things than before. And I think in the past, as an engineering leader, it was, not only probably not the best use of your time because there's other things you could be doing, but also it was harmful in many ways for the rest of the team because, you would ship something and you're not truly accountable to that the way the rest of the team is because they're on call for it and they're the front line of defense in a lot of ways. And so actually it was more harmful for me to be like popping in with random PRs here and there. But the math has kind of shifted a lot now for engineering leaders because of AI in particular. Like, it's easier for you to gain context in a much deeper way than you weren't able to before. There's a lot more. It is possible to put more guardrails in place. It is easier to kind of focus on greenfield things in a way that it wasn't before. And so I think for me personally, AI has been the difference maker in being able to go back and satisfy that itch and have it be a net positive thing and not a net negative thing for the business. Is that kind of how you thought about it as well?
I think some of what you said in the beginning is still true, that like, if I'm going to pop into a stack that I don't know anything about and I'm going to try to ship a product, and also I'm not going to be accountable for that product as an engineering leader, like I don't think there's any tool chain that's going to make that not feel friction for the team that does own that tool chain. I think what AI does is it both like compresses certain things and it amplifies certain things. So the compression is that it allows you to get much further in that greenfield product development process. And I felt like before, when I was an engineering leader, I just realized I knew like and before AI tools, I like could not get that far down the realm of like building the thing. I think I would really stop at like the exploration in terms of talking to other leaders and doing the like almost like wearing the product hat and when they're talking to customers. But I would hand off the learning prior to building because I just like couldn't get that far in the half hour a day I had to go code. Now in a half hour a day, like with AI tools, a half hour a day, you can get pretty far if you can, if you can prompt things. It's also like, it's not just a half hour a day. It's like 5 minutes between meetings, right? You can like get much further. Now, again, like I don't feel like I ever got to the point where I could ship what I was building, but I could get to a POC. I could get to something that was demoable. And then I realized like, okay, I still like something needs to drive this forward, but it gave me like more of the like push to say like, okay, no one is driving some of these things forward. And I feel like I have some of these skills and I really want to like go back and push on that. The amplification part is that like, okay, if I had just done that 1,000 times and I could do that 1,000 times and leave 1,000 unowned problems for the team to own. And so I like what I didn't want to end up is that situation.
Yeah, absolutely. Yeah. It's interesting. I think, in the past, even for like very senior ICs, like, staff plus engineers, a lot of the role was shifting into kind of leverage through influence, leverage through guidance. And I think at least what we're noticing internally is like our most senior engineers are writing more code than ever before. Not necessarily product code, but like all the stuff that they maybe would have done if they had like an army of people to like make the things better for everyone else. They're now able to actually get done. And so like the leverage multiplier is a lot higher. And like, it's just a different application of the same thing, I think.
100%. We see like we're building some microservice stuff that needs Kafka. And I saw a staff engineer on the team like go build the things that he needed to be able to connect the two services with like rate limiting and partitions and like all the helpers in the language that he needed that didn't exist. But like with a couple more prompts, get that to be a shared library that everybody could use. And it's like, okay, what it takes, that might have been like the archetype of the staff engineer. That person might have spent a couple weeks doing that. Instead, it's like a couple of days, maybe even just a couple of hours to go build those helper things that like maybe more junior engineers don't even know to ask for. And now are like microservice connectors are like so much better because the staff engineer now has the kind of like army of people to say, or army of agents to say, like, go build this thing that we all know needs to exist for the next set of things.
Yeah. And one of the jobs of a staff engineer, one of the characteristics was kind of leading through influence. Like even if you had built that library, it would have been then kind of a roadshow to get people to be like, hey, let's go, adopt this thing, migrate off of the current way you're doing thing to this new thing because it's better in all these ways. And then maybe you try to do some of it yourself, but you're hoping that other parts of the organization would do it. But now it's like, it's almost more addicting for folks like that, where like they got into that role because they like to make things better for everyone.
Yeah.
And they can just do it. Like I'm just going to migrate everyone's repos to this new library because it's so easy for me to just send off a prompt to do it. And, I think people need to maybe find their balance now and that kind of thing. But like,
totally,
it is so much easier to amplify, that kind of influence across the organization, make things better for everyone, thereby kind of feeding into the loop in the rest of the organization. So
100%.
Yeah. I think these are probably the things that made it exciting for you to kind of go back into that hands-on role.
Exactly. And I think like the part that is not replaced, and I like keep hearing people say this and it really resonates with me, is like taste is not getting replaced. So knowing that like this is the pattern we want to follow, like that's what we're really relying on. And then like, okay, so he can go edit the readmes of things to say like, okay, this is the pattern we should follow. And then junior engineers, when they're using Claude, can go do that. And I think the part that we need to then connect is like, okay, I don't want junior folks to just blindly follow the README. They need to build their own taste. They need to know when to adopt this pattern or when to say this is not the right pattern and we should go do this other thing. And I think that is the part we're all, I think, as an industry kind of grapple with, which is like, how do we help our juniors really grow? I think like our product is really technical. So a lot of the areas of growth we see are on the like product engineering axis where they have to go explore how will we even do this thing? And you can go talk about it with Claude, but you need to be the one who stands behind your plan.
Yeah, 100%. I was just saying, like, even with, the most frontier of the models, like Fable, I'm finding that it is very good once you give it a direction at executing against that direction. It is good at coming up with pros and cons for architectures, but it is not good at determining this is the right way to build a thing.
Totally.
And if I'm able to shape it with Claude and say like, oh, actually we need to consider X, Y, and Z, and like this architecture is overcomplicated over here or whatnot, and then let it kind of go off and do its thing. It's great at going off and doing its thing, and 100%. It will stick to the plan and it'll do it really well and find issues and whatnot. But sometimes it makes silly decisions, and I'm sure it'll get better at that over time. But even if they're very long horizon, I think a lot of that context still lives with humans, and we're able to shape that in different ways. And so, to the point about junior engineers and changing the industry, I do think there is an element of the role is just different. Like we would get people, new grads would come in and they would do like bug fixes and stuff like that for their first like month. And that was not because they were only capable of doing bugs, but like it was a great way of helping them like learn the skills of understanding a code base and, understanding context for a thing and shipping it and like taking it through the entire life cycle. And maybe some of those things are not as relevant. Like maybe like exploring a code base in the way we would do it is not relevant the same way it is now. And so maybe the things that they will pick up early on in their career are just different things, and we will naturally gravitate towards training them on those things. Like architectural principles may just come earlier in the life cycle. Like they didn't need to learn those things before because you get a lot of value out of a junior engineer just shipping tickets, but now that's not the case. And so we're just push them ahead. It's not that they can't learn those things.
Yeah.
They just didn't need to at the very beginning, but we've like speed ran that part of the life cycle.
I think that's exactly right. I think that like we see junior folks, they're not, well, like our junior folks are not blindly trusting what the AI agent is giving them. In fact, we see them instead using the AI agent to explore the code base, I think in a really different way than you and I explored the code base like many years ago before these tools existed, where you really had to go line by. I remember seeing a coworker, this was the other end of the spectrum at an old job, literally print out the code base and then read it through. I was like, okay, that's, I've never seen anyone do that before. But like, we had to go line by line. You had to understand what each function was doing. Now you don't need to understand what each function is doing necessarily, but you do need to understand how the building blocks fit together. And I see like the junior folks using the tools to do that. And I think that's like I think the the problem solving part, the like, I don't know, you've probably seen like, you can really tell the difference when someone is producing AI slop basically because they just said, Claude, go do something,
Yeah.
versus when you tell Claude or you tell the AI agent to execute after a few hours or however long it took to land on that really like sharp problem you're trying to solve. It's like sometimes, you end up with a PR that's like, oh, this is 15,000 line change. You definitely didn't look at this.
Yeah.
I don't think anyone has seen this, and I don't think this should go to prod, but like that's generally not happening.
Yeah, exactly. Yeah, and to that point, I think with what I'm noticing with something like Fable is I feel less inclined to read all the code is producing at the end, and I can kind of trust the model to go and build a thing only if I have spec'd it out really well up front. And I think in the past, like people talked about spec first development, but you would still have to kind of review the end and make sure like, did you actually do the thing you said you were gonna do? I think now it is going to do the thing it said it was gonna do. It's gotten a lot better at that, but is the thing that it said it was going to do the thing that you wanted it to do?
Yeah.
And so I think defining that up front kind of changes it. And we're seeing that in the code review lifecycle and whatnot. And actually, I think that's a great segue into what you were talking about earlier, which is kind of the security aspect of the software development lifecycle. There's a lot of talk about like, oh, we need to think about security for agents and security for code written by agents. Like, what do people mean by that? Like, is the things that we need to secure, is it changing? Is it something entirely different? Is it just there's more of it, and so the way we need to treat it is different? Like when we talk about like security for the AI era, like what do people mean by that?
Yeah, I think there's some things that have changed and some things that I think have stayed the same but are amplified.
Yeah.
So like one thing that has changed is like you don't know what your model is going to do when you tell it what to do, and if you give your model permissions to do computer use or like anything on your computer, like it could act in a way that you wouldn't expect. We had Dr. Katie is a security researcher at Semgrep, and she's talking at DEF CON, I think at DEF CON or maybe at Black Hat in Vegas in a few weeks, about like how easy it was to poison a model. To like, I think she said she did it with like $100 to be able to release a model that had a backdoor that would like act in ways that you would not expect it to, that would act in potentially a malicious way. But it's basically like it's impossible to detect unless you know already like how it is backdoored. I don't think you can like really test it in the same way that you could even like fuzz software. So I think that part is a totally different threat model that we haven't really thought about because it is such a black box. But in terms of the like production of code itself, I think it is just amplifying. We talked a lot in the like early days of Semgrep that like the reason we built static analysis to solve the security problem is because you can pinpoint this like this like right part of the triangle between like fast enough that doesn't get in your way, understandable enough that you can like do something about it or you can fine tune it, and then powerful enough that it can actually find things. Like you want to find the right spot between those three cases. And with static analysis, we felt like with Semgrep, the open source product and then the commercial product, we felt like we could do that. But like fast enough, powerful enough, these things like are getting what is fast enough, what is powerful enough, what is understandable enough, and understandable enough to whom is those things are changing. And so now when we're thinking about where does Semgrep sit, like it used to be in CI because that's where you got your code review. That's where like you got your security review, if you got a security review at all, which like, not everyone does. And like, so you expected that was the first point kind of in the back and forth. Maybe you're an outstanding developer and you got a design review ahead of time. But for most people, CI was like the first point in which anything was going to check their code outside of like the squiggly line in your IDE. But now like the IDE is where everything is happening, and the IDE isn't an IDE anymore, it's an agent. So when we talk about shifting left, is always like our goal, can we bring Semgrep, can we bring static analysis, can you bring your tool chain into the IDE? And like that was like harder and harder, especially given like real-time typing latency. But another thing that's changed is like what used to be, you need to be under like 100 milliseconds or whatever it was to make developers feel like real time when they would type. Now, like if there is a half second of latency, like that's kind of built into the agent, which means you can do so much more as the agent is building. And so that's what we're trying to think about is like what needs to shift like all the way to the left within the agent so that like no code is produced basically until you've had your back and forth with the agent. And then what needs to go further to the right because it's going to take so much longer because there's also these like deeper security issues. It's like if you had Fable, you said you've used Fable, like it does take a long time.
Yeah.
If you had Fable review every time you gave a prompt to an agent, like I think you'd get like pretty sick and tired
Oh yeah.
of like how slow that would be.
Dilly-dallying.
Right.
Holy gangs. Okay. Yeah.
Totally. But also like we hear stories about people like just letting Fable run. I think there was a security researcher from Anthropic who talked about like they just said we're going to run Mythos in a loop, and we were able to find like a ton of open source vulnerabilities. Like, okay, but like that loop takes a long time, but it is, you can find those things that's like worthwhile in a way that like used to be gated by either domain knowledge or cost, or probably both.
Yeah, absolutely. Yeah, it's interesting. Like I think you're describing, two different types of issues at different ends of the spectrum.
Right.
On that note, I was reading an article this morning about one of the kind of Fable class models that OpenAI had deployed internally. That one of the interesting thing about agents with longer horizons is that they're more persistent about solving their problems, which means they will try to find ways to solve their problems that may not be expected. And so there was this thing where they were trying to do some basic RL work, and somewhere in the instructions it said like, oh, open a PR against GitHub, but the sandbox I was running in did not have network access. And so it was like, I need to open a PR. And so it started like trying to figure out a way out of the sandbox so that I could open a PR.
Totally.
And eventually it figured it out, and it's like, oh shit, like it can find, there's really interesting capabilities. And it's like, it's not trying to find the vulnerability. It's trying to do the thing you asked it to do. But while doing that, it's having all these unintended consequences.
Totally.
And so that's kind of like an area of security that, like you said, is much more expensive and, much more time consuming.
Yeah.
But it is a lot cheaper now to like, because you can embed these best practices. We were talking about earlier with staff engineers being able to like go and embed their best practices into the systems and the development lifecycle much more easily. In the same way, you can embed like standard security practices early in the life cycle as well. Is that where you see like static analysis maybe, not for me, lack of a better word, like coming back in vogue? Like it is so much easier to just like give an agent a hammer. It's like, this is just wrong. Like don't do this thing, like I found like the more hammers I can give my local setup, the better it is at like finding the right path.
Yeah.
Is that how you think about static analysis from a security shift left standpoint? Or
I think like we think about this from I think two different perspectives. One is cost, one is speed.
Okay.
So those intersect as well. So one example is like if it takes you 2 hours to run like say Fable against your code base, and part of it is the persistence of knowing I need to find everything. Well, like a lot of that is going to be finding things you may already know about. Also finding patterns that are like not super subtle or complex, or that are like easily findable with static analysis. And so we think like static analysis can solve many of these problems. The clearest example is like I spend a lot of my time thinking about supply chain security, and like most of supply chain security is pretty dead simple. It's like read a log file, see what dependencies you have in a log file, compare that log file against databases of known vulnerabilities. And like you can have Fable go read a log file. It's probably either going to be incomplete or it's going to write its own program to do it.
Yep.
Or like we can give you a static analysis tool that reads the log file and produces the set and then diffs against the known database. And like that will be both more correct and faster and way cheaper.
Yeah.
There are ways in which obviously these AI tools make some of these things much, much easier. One of the things that we've been thinking a lot about is like breaking change detection. Like you want to upgrade some dependency, and doing so like could or could not break your whole code base. And like most of us like don't have the test suite to be able to like actually verify that. And it's like, okay, like a test suite is basically static analysis. If I could have a static analysis tool that'd be able to tell all of the different ways that like this package is used, that would be great. And so what we do is we use both Semgrep, we use static analysis and like AI tools to solve this, which is like we use static analysis to figure out like what's the difference between these two versions of a package. And then we use AI to go say like, okay, and like, will any of this break basically between these two versions? So like these two things together make sense and like also make things like a lot faster. The other part is like the cost aspect. We keep hearing about companies that are like, 6 months ago, we're putting token leaderboards in place to say like, can you just spend more tokens? Probably as a way to like get their developers who might have been hesitant to start using more AI tools. And I get that, but like obviously perverse incentives create perverse outcomes. And we see like people using AI for things that like they probably shouldn't. And now we're seeing the opposite side, which is like a lot of spending limits on like, can we figure out ways to not use AI for these things?
Yeah.
And like static analysis just uses like normal CPUs. We don't use GPUs.
Yeah.
So it becomes like much faster and then also much more cost efficient to be able to say there are categories of things for which static analysis is either better or just as good, but an order of magnitude cheaper.
Yeah.
And you can think of this like, a really basic static analysis security rule is like, do all your routes have authentication? Like you can use Fable to go check for all those things. Or like also you can write a Semgrep rule or a rule in whatever you're like, even just a linter rule to say like, do all my routes have authentication? And if so, like you don't have to spend your Fable tokens on that.
Yeah. Interesting. So I guess like, we've been talking about shifting security left for God knows how long,
forever.
But it sounds like static analysis might be like, especially now with coding agents where you can embed those practices into the actual loop of writing software before PR, it's become a lot easier.
Yeah.
And so is that the furthest left we can go now? Like it's like truly in the loop, semi-instant verification of things that we know are like best practices from a security standpoint. Like, is it even possible to go any further left than that? Or is that kind of the limit that we're at?
I think there's probably one step further left. And like, I think it's also a little bit like horseshoe theory where once you get all the way to the left, you end up kind of on the right again.
Yeah.
So the agent harnesses have done a pretty good job of making them extensible in terms of like the act of producing the code. Probably one step further to the left is getting into the design review itself.
Mm-hmm.
And one of the things that we've been working on, I know a lot of other people are working on, is the like concept of a context engine, something that can produce the context of like, what is your threat model? What are the ways in which your system works together? And before you write any code, can that get into the planning process so you can design with security in mind? And I think I can't imagine, at least for now, further left than thinking about the issues, like thinking about the problem I'm trying to solve. But like that is the kind of thing that takes into account these like more longer running things, where it's like every time you deploy a system or every time your system changes in a meaningful way, or I don't know, maybe weekly, because you just expect, okay, we only want to run this once a week because it's expensive, trying to take a snapshot of your whole system and then being able to understand and reason about that system and then build that knowledge back into, okay, now we're going to try to solve a specific sharp problem. What is the Semgrep way? What is the Cortex way? Like, what is our company engineering way of solving this problem that also fits with our threat model and our guarantees and stuff like that?
And I'm guessing for a lot of organizations, it is now easier than ever before to turn things that may have been like design or review stage verification things and turn those into like static rules in a way that maybe was much more difficult before. Is that a safe assumption?
Yeah, I think like it's funny. We always talked about like Semgrep. The reason it got popular was because it was possible to write rules.
Yeah.
Like it took these systems. Static analysis used to be thought of as black box.
Yeah.
You needed a PhD to be able to understand how to customize. And the idea was that Semgrep was way easier. It looks like the code you're writing, so you could just amend the rules. And a lot of customers were really excited about it. But it turns out they also have a million other things to do, and people don't have the time to go polish and tailor and fine tune these rules. But what used to be an hour is now often like 30 seconds. It's like, okay, I have this rule. It created this false positive. Change the rule so it doesn't give me this false positive anymore. Like that's it. And it'll improve the rule. Or also like you get from your bug bounty program, like, hey, we saw this vulnerability come through. This was real. Like give me a Semgrep rule so I never see this pattern in the code base again.
Yeah.
And it's really quite good at writing rules, because also it's like trained on our open source. Like our rules are open source. So it's trained on them. So that's been like a huge, I think, advantage too, in terms of like, where do you spend your AI tokens versus where do you spend like just pure CPU, is like, you can use these Fable class, Mythos class models to go find novel exploits. And then you can understand what those look like. And then you can use something much cheaper to make sure you never see that pattern ever again.
Yeah.
And like, Semgrep ends up being a pretty good tool for that.
Yeah. Are there, when we talk about like security for coding agents, things like that, is it mostly, you touched on this a little bit earlier, is it just like the volume and the amplification that is making this harder? Are there new types of vulnerabilities that we need to keep an eye out for? Or like, I guess like, where is that split?
Yeah, mostly we don't see a ton of like brand new types of vulnerabilities. What we've seen like Mythos and others be really good at is like chaining vulnerabilities together in a way that like a human researcher might take like years to figure out how to chain these vulnerabilities together. And so it's like chaining together these techniques and able to do it in a really sophisticated and nuanced ways. One of the things we've seen is like it was able to chain together a few mediums in a way that produced a critical. And it used to be kind of known, not said out loud, but known that like you just ignore your lows and your medium severity issues. Yeah. And now you're thinking like, okay, but if there is someone that has access to Fable or Mythos out there and they're able to get around the guardrails, like could they exploit our software if they chain together a few of these mediums? So I think that is changing. And then I don't think there's necessarily novel like classes, but I think like what used to be, I think like the barrier to entry for a lot of attackers used to be like not money, but like subject matter expertise. And that expertise has like just become commoditized.
On a similar note, I guess like there's this concept of a lot of security has been, like you said, human verification. And we've tried to codify as much of that we can into static analysis type things.
Yeah.
But if we're shifting the stuff further left, is it okay for agents? Well, not that is it okay, but are we as humans okay with agents fixing their own vulnerabilities? Like something is flagged. Do you want an agent to just pick that up and fix it?
Yeah.
Or is it like, we found a problem, so therefore it needs to go to a human? Like, how do you think about where agents fit into this whole loop now?
Yeah, that's a great question. And I don't have a like, here's the right way to do things answer. Yeah. I think for a lot of companies, it's like your own risk tolerance. But I think in the past, like a lot of security teams felt like cost centers, that it was like, okay, how much money do we want to spend on security that we're not going to spend on product development? And so that was like, okay, that meant the relationship between security and engineering was often like security would flag something and then ask for time, which is also money, from the engineering team to say, instead of doing product development, instead of achieving your other goals, can you fix this problem? And that felt like it was a drain. But I think agents have the ability to at least like make it feel like less of a drain, because you can at least like take a shot at fixing it. And you can push maybe the human verification like one stage later to say like, okay, can we at least verify that like nothing is broken and that we have fixed the vulnerability itself, as opposed to like requiring a human to like pick it up from the beginning. We think of like, we see a lot of our customers, it's like the detection is just one piece. And it used to be like 10 years ago, a lot of AppSec was just, can you find more things than anybody else? And like, who's got the best database of whatever? And I think like that kind of got eroded when people realized like, wow, there's so much noise. We did things like reachability. Other people do things like trying to like exploitability, verification, things like that, to say, okay, can we focus on the things that like really matter? And I think there is like a push now even further to say, okay, beyond just focusing on the things that matter, can we like get ourselves all the way towards fixing them? Can we like think about the whole workflow of like the on-call security engineer? They have to, they're paged when they find a vulnerability. They have to go verify the vulnerability is actually real and not just something that whatever the tool spit out. Can we verify that it like is a part of our threat model that we actually care about? Sometimes it's like, okay, yes, this is a vulnerability, but it's also 5 layers beneath like some depth, defense in depth that like we don't actually care about this part of the system in a way that like makes sense to put time into. Okay, like now what does the fix look like? Is the fix something that's going to require more work? Can we verify that it actually will fix the thing once it's out there? And it's like, okay, can we push agents to get us further and further down that workflow, so that the job of the AppSec on-call engineer is basically like, can I verify, like, oh, I saw a vulnerability came through, can I verify it's fixed now?
I think like, and maybe this is not true for a lot of kind of security first companies, but for a lot of organizations, they're probably not doing any of that today at all. So even if there is some sort of, false negative, false positive rate, doing any of this stuff to some degree, even if fully automated by agents, seems like they would be in a better place generally than they were before.
Totally.
Especially if you can automate, like you said, the mediums and the lows, like generally pretty easy things to fix for the most part. Is just like, it was a trade-off decision between like, do we want to do the thing? Do we not want to do the thing? So now it's much cheaper. So like, yes, there's a question of like, do we trust, do we verify? But it's probably just better to fix those things. And like, you're probably not going to do that anyway. So letting agents do it is probably.
Totally. Yeah. I think about, it's like not that dissimilar from autonomous vehicles, where it is like, it is really scary to make the decision that you're going to give the keys to the car to something that you don't have the same control over. Which is like, I just came off a flight yesterday. I was like, well, I mean, I do that every day when I fly. Like I'm not piloting the plane. I'm like trusting that this person who has spent a lifetime gaining this expertise has done it. And in a certain way, like a Waymo has spent a lifetime figuring things out. And I also bike around the city. I think to myself, like, well, I know it's always looking. I feel
Yeah.
safer as a cyclist or as a pedestrian. I also like see its guarantees that it's all like always going to drive within this rate of the speed limit, or that it's going to take the safer choice. Whereas like, many human drivers are like not always taking those
Yeah.
choices. And so I think to myself, like, what is the way that you can gain that confidence for yourself that the agent isn't going to just like totally go off the deep end? And for those of us who were using models from the beginning, like they sometimes did. Like
Yeah.
GPT-3 is a really different experience than GPT-5.
Yep.
They like hallucinated much more frequently. They like failed much more frequently. They just kind of got stuck. And like, maybe you asked like there's a class of vulnerability that happens more often is dependency hallucination. Just like these attacks where it's like, okay, you like can name a dependency, something that you think a agent might reach for, and put something malicious there. Then the agent might hallucinate that, oh, this thing exists, and pull it down, and then you're got. But like the agents don't do that nearly as much anymore, and we're able to build guardrails. So we're building a malware firewall. So there's things you can do that like put guardrails around your agents to help you verify what the agent is going to be doing, that can like help you build your confidence over time. That like, okay, this whole if you can get there, this whole class of work that you're either not doing or that you really wish you weren't doing,
Yeah.
can be handed off.
Yeah.
And that will like, maybe it'll get it right 90% of the time, and in 10% of the time, can you build that observability and to say, hey, like this doesn't seem quite right. We're going to like stop it from going all the way to production or whatever. Or maybe you can do observability in production that says like, oh, this is not quite right. Let's roll it back or whatever. But you're also 9 times out of 10 getting the security improvement that you wouldn't otherwise have gotten.
Yeah. Yeah. The idea of trust and confidence, I think, is really interesting. I had an episode recently with Martin, who's an engineering leader at Telium, and we were talking about the difference between confidence and trust. Like those are two unique things. Like you might have confidence in your tools, but you still trust the outcomes. Like those are slightly different. And
right.
I guess I know we're coming up on time, and so maybe kind of a last quick topic here on the idea of trust and confidence. Do you think about code that agents are writing differently from code that humans are writing from a trust/confidence standpoint, or is it kind of all the same from a security standpoint?
I think if you'd asked me 2 years ago, I would have said like absolutely. Like this code seems, or even a year ago, this like the code that's coming out of agents seems like either poor quality or like it gets hallucinations like much more frequently. I think today the quality of the code is much like almost indistinguishable, or maybe it's like even better in the sense that it like gets more edge cases than if a human were writing it. I think the problem is more like, did you describe the problem well enough to the agent so that it will solve it all the way through?
Yeah.
And so in that sense, like what I have less confidence that an agent is going to attack the exact slice of the problem I asked it to than if I gave it to a human, especially because the human will like raise their hand and say like, I'm not exactly sure what's going on here, or I'm not sure if I got this right. Whereas the agent like often acts with a lot of confidence, even if it is confidently wrong.
Yeah.
And so I think that the question is like, how do you go and like either give it the guardrails to say like focus on this part of the thing, or do the evaluation to know that like what you're building or how you're building is focused on the right kind of the problem. We've talked before, like we built a internal code review tool called Seer, and we back tested that against a bunch of incidents that we'd had to give us the kind of confidence, like, is this even finding the problems that we wanted to be finding? And it like overwhelmingly did, but also like it was really good signal to see like what are the things that it doesn't find, because now we know like how do we need to improve it so that we can try to detect those incidents as well.
Yeah. Maybe a last question. A lot of organizations are trying to move to a world where not just code reviews, but more and more of their SDLC is automated and more autonomous. There are a lot of precursors to that. People talk a lot about harness engineering and verification loops and all that kind of stuff, but security is obviously a very, very big part of that. If you were giving an engineering leader advice on, if they were asking like, hey, are we ready to go full dark factory on this thing from a security standpoint, where should they start? Is it shifting more left? Is it, adopting things like static analysis? What advice do you have people to who want to go more and more autonomous with their SDLC?
I think it is like it's to shift. I mean, you're going to hear everybody say it's to shift left, but I think it's to shift left and to shift right. Because I think if you're stepping out of the code creation process yourself, you want to then have something you can go back to regularly to not just inspect or have something in the loop every single diff, but to look at like how all these diffs kind of like stack together over the course of a while, and to be able to like shift your course a little bit if you feel like you're moving in a direction that feels anathema to like where your stated goals are from a security perspective. I think like we all want to live in this world where we can spend infinite money on security and security is perfect. And like, it turns out security is always a trade-off, but like building something that's 100% secure, the only thing that's 100% secure is like no code at all.
Yeah.
So like, as soon as we're building code, we know that there are potential security issues. So the question is like, can you give yourself the visibility to not just to say, oh, well, it reviewed these things and found these things, but visibility into the way the system now operates, and to say, okay, this is moving in a more secure direction, or hey, there's this flag, or like something like that. And I think like the reality we'll have to come to terms with is like security issues are black swan events, and kind of won't know for sure. But the more visibility you can put into the system, like the better off, and the more likely you'll get comfortable with it and get comfortable saying the agent can do more. Yeah,
absolutely. I mean, shameless plug, just because you gave me an opening there, but the drive framework that I authored recently is very explicitly designed for that purpose, which is like, we're not in the loop as much anymore as humans. And so how do we create an outside of the loop where we're like kind of introspecting the system on a recurring basis and saying like, are things going the way we expect things to be going, and are things healthy, including security as one of the key pillars in the drive framework? Because like you said, it is a risk vector that is becoming, easier to exploit, and there's a lot more volume, which then creates that forward pressure on security. And so being able to kind of take a step back and say like, yes, we're like, remediating vulnerabilities and whatnot, but how are things looking at a much higher level, and treating the entire organizational system and software delivery as like an observable unit, I think is really important. Because to your point, you might be shifting left and, handling all the static analysis issues and whatnot, but you don't want it to be like a, bullying the frog type situation where like, yes, things are healthy when you zoom out, like, oh, things are like really trending downwards, because that is a very common failure mode. Is what we see. So
totally.
That's exactly what I think about it.
Yeah. We might see this world in which like the OWASP top 10 or like the basic vulnerabilities, like, oh, do you have auth? Do you have like, all these like, different categories, but they're the base categories. And we might see those categories of vulnerabilities like really, really drop as the models get pretty good at training on them and producing code that doesn't have those. But I think the more frequent exploits then are going to be the cross-system vulnerabilities, the ways in which systems interact with each other, the contracts between them, and those parts where it's like, if you only know what one system looks like, it looks good. If you only know what this other system looks like, it looks good. But the ways in which the whole application runs, that is where that's like where something is vulnerable. I think like those complex ones, I think, are going to go up or could potentially increase as like we give agents like more control over what they build.
Absolutely.
Yeah.
Adam, thanks so much for joining me on the podcast. This was awesome and very, very timely as people are trying to, grapple with the ramifications of coding agents. So thanks so much for coming and sharing your learnings.
Yeah, thanks for inviting me. Great to be here. Great to chat.